These are solutions to Calc 1, Exam 4. Question number 1, find the critical numbers. So please note that the domain is all real numbers. You can plug in all numbers that you want. You're allowed to even put in negative numbers because you can take the fifth root of any negative and then raise it to the fourth power and so forth. Okay, so the derivative, use a product rule. First times the derivative of the second plus the second times the derivative of the first. A little bit of cleanup. I get 2x minus 4 times x to the 4/5 plus 4/5 fifth root of x minus 2 squared. I get an x in the denominator, so that automatically makes x equals 0 a critical number. So for a critical number, either the first derivative is undefined or it's 0. So now I set it equal to 0, set the first derivative equal to 0. I already know x equals 0 is a critical number for my answer. So I set this equal to 0. I will multiply both sides by x to the 1/5 to make it nicer. I factored this back out into 2 times x minus 2. X to the 1/5 times x to the 4/5 is just x to the 1. And this is x to the 1/5 in the bottom. So if I multiply by x to the 1/5, it just disappears. So I have a much nicer equation here. Factor out the x minus 2. I get 2x plus 4/5 times x minus 2. Set that equal to 0. This is easy. X minus 2 is 0. This one, 2x plus 4/5 x minus 2 equals 0. Multiply both sides by 5 to make it nicer. This one I get 2. This one I get 10x plus, cancel the 5, 4 times x minus 2. That comes out to be 14x equals 8. So x is 8/14, or 4/7. So my critical numbers are 0, 2, and 4/7. Number 2, absolute max and min. Plug in the endpoints. Plug in 0, you get 0. Plug in 2, I get 2/5. And then critical points. So I take the derivative and set it equal to 0. Quotient rule, bottom times the derivative of the top, minus top times the derivative of the bottom, all over the square of the denominator. That's x squared plus 1 minus 2x squared, which is 1 minus x squared. Set that equal to 0. 1 is a fraction equal to 0 when the numerator is 0. So that gives me x is plus or minus 1, but I can throw out the negative 1. We're only going between 0 and 2. So my only critical number is at 1. Okay, so I plug in 1, I get 1/2. Okay, so I just look at the 3 function values. At the critical number, I have 1, 1/2, and the 2 endpoints, I got 0, 0, and 2, 2/5. So that makes the absolute maximum 1, 1/2, and the absolute minimum is 0, 0. Number 3, the function is a parabola, so therefore it's always continuous and differentiable. Therefore, it's continuous on bracket -1, 1, differentiable on parentheses -1, 1. So the hypothesis for the mean value theorem holds. Okay, so I plug in 1, you get 9. Plug in -1, you get 5. So I find the slope of the line joining 2 endpoints, f of 1 minus f of -1, divided by 1 minus a -1. That's 9 minus 5 divided by 2, or 4/2, or 2. So the mean value theorem says somewhere between -1 and 1, the slope is 2. So somewhere on -1, 1, f prime of c is 2 for some c as an element of parentheses -1, 1. And that's easy to do. Take the derivative, 6x plus 2, set it equal to 2. That's easy, so c is 0. So the c value is 0, and that is between -1 and 1. Number 4, okay, so f of 0 is 0. That's the origin. F prime is greater than 0 for all x. That tells me the function is always increasing. It's always going up. Okay. And then f double prime is less than 0, means concave down for x less than 0. So CD here and CU here, f double prime greater than 0 for x is greater than 0. So concave up. So goes through the origin, always increasing, always going up. First concave down and then concave up. Number 5, perfect example of L'Hopital's rule a couple of times. Plug in 0, you get 1 minus 0 minus 1, which is 0. The bottom is 0, 0/0. So LHR, L'Hopital's rule, take the derivative of the top and the bottom, e to the x minus 1 over 2x. You still get 0/0. Do it again, LHR, L'Hopital's rule. Limit x approaches 0 of e to the x over 2. Now I plug in 0, and the answer is 1/2. Number 6, natural log of sine of x. You can only take the natural log of positive quantities. So I want the sine of x to be greater than 0. That's in quadrant 1 between 0 and pi, but we have to account for the fact that you're going all the way around and so forth. So I write 0 pi union 2 pi 3 pi dot dot dot, and going the other direction, union -2 pi -pi dot dot dot. Okay, number 7, the curve sketch. F of x is x e to negative x, which can be written as x over e to the x. Intercepts are 0, 0. The domain is all real numbers. Okay. End behavior. Limit x approaches infinity of x over e to the x. L'Hopital's rule, that's infinity over infinity. Derivative of the top is 1. Derivative of the bottom is e to the x. And now we get 0 plus. 0 plus means the graph approaches 0 from above. So horizontal asymptote, y equals 0. There are no vertical asymptotes because the function is defined for all real x. Okay, f prime of x. So first times derivative of the second, x times negative e to the negative x, plus the second e to negative x times the root of the first, which is x. After some factoring, I get 1 minus x e to negative x. F double prime, first times derivative of the second, 1 minus x times negative e to negative x, plus the second e to negative x times the root of the first is negative 1. The opposite of 1 minus x is x minus 1, factoring out an e to negative x. So I get x minus 2 e to the negative x. All right, and so these critical numbers, I'll plug in 1 right here. So if I plug in 1, I get 1 e to negative 1, or 1 over e, which is about 0.37. Okay, what makes this 0 is 2 comma 2 e to negative 2, or 2 over e squared, which is about 0.27. Okay, so that's what I get if I set f prime equal to 0. 1 minus x e to negative x equals 0. E to negative x is always positive. So what makes this quantity 0? 1 comma 1 over e. Do a sign chart. Plug in 0, I get positive. Plug in 2, I get negative. Remember, this is always positive. So increasing, decreasing. So the function is increasing from negative infinity to 1, decreasing from 1 to infinity. Therefore, I have an absolute and relative max at 1 comma 1 over e. 1 over e, and there's no minimum. Set f double prime equal to 0. Set that equal to 0. This can never be 0. It's always positive. So x is 2 comma 2 over e squared, which is about 0.27. Sign chart. Recall that e to the negative x is always positive. If I plug in 0, that's a negative. Plug in 3, it's positive. So the function is concave down from negative infinity to 2, concave up from 2 to infinity. Inflection point 2 comma 2 over e squared. And here's my graph. Goes through the origin, increasing up to 1 comma 1 over e maximum, decreasing, still concave down, then switches to concave up at 2 comma 2 over e squared the rest of the time. Number 8, y equals 2x minus 5. Here's x comma y, x comma 2x minus 5. Here's the origin. Use the distance formula. F of x is the square of the distance, is x squared plus y squared. And I want to minimize this quantity. So that's x squared plus 4x squared minus 20x plus 25, or 5x squared minus 20x plus 25. So f prime is 10x minus 20. Set that equal to 0. X is 2. F double prime is 10. 10 is greater than 0, which means I have a minimum because I have a concave up situation at a horizontal tangent. So that proves I do have a minimum. You should show me this step also. So I know x is 2. Plug back in. Y is 1. So we want the point. We don't want the distance. It just asks for the point. So the ordered pair is 2 comma negative 1. Number 9, factor x squared minus 4 in the denominator is x plus 2, x minus 2. So as x approaches either positive or negative infinity of this quantity, we approach 0. So horizontal asymptote is y equals 0. Vertical asymptote, x is plus or minus 2. And finally 10, Newton's method of approximation. I have x equals radical 2, square both sides, set this equal to 0. So the function that I'm trying to solve is x squared minus 2 equals 0. F prime of x is 2x. They tell me the first guess is 1, so I plug in 1. And then take the answer minus derivative over original. So, function over derivative. So answer squared minus 2 over 2 answer, just the way I type it in. X2 is 1.5. Do it again, 1.417. Do it again, 1.414. Do it again, it's still 1.414. So the square root of 2 to 3 decimal places is 1.414. All right, so those are solutions to exam 4 for Melham's Calc 1.